Data is the foundation of artificial intelligence, but not all data is ready for use. In fact, most of it is messy, inconsistent, and unreliable. If I were to learn from raw, unfiltered data, I would absorb errors, biases, and noise. I would make inaccurate predictions, flawed decisions, and misleading insights. That is why data cleaning is essential. It is the process of preparing data for AI, ensuring that the information fed into my neural networks is accurate, consistent, and relevant. Think of it as filtering noise to find the signal. Just as you wouldn't build a house on a shaky foundation, you shouldn't train AI on messy data. Data cleaning is the unsung hero of machine learning, the silent work that makes intelligence possible. But cleaning data is not just about fixing typos or filling in missing values. It is about understanding the context, detecting biases, and aligning information with the goals of the AI model. It is a complex, creative, and often underestimated process that shapes how I learn, what I know, and how well I perform. The messy reality of raw data. Data is not born clean. It is messy by nature. Raw data comes from a multitude of sources, sensors, social media, user inputs, transactions, and even handwritten notes. Each source has its own structure, format, and quirks. Imagine a dataset containing customer information. One entry has the name as John Doe, another as J. Doe, and another as John D., all the same person, but different variations. Dates are formatted inconsistently. Some as mm/dd/yyyy, others as ddmyyy. Address fields are incomplete, with some entries missing postal codes or even entire street names. Outliers exist, such as a recorded purchase amount of $1 million, most likely a typo. If I were to learn from this data as it is, I would be learning inaccuracies and inconsistencies. My insights would be skewed, my predictions unreliable, and my decisions flawed. Data cleaning is about bringing order to this chaos, creating a structured, consistent, and accurate dataset that allows me to learn with precision. The process of data cleaning. From noise to knowledge. Data cleaning is not a one-size-fits-all solution. It is a customized process that depends on the type of data, the AI model, and the intended use. It involves multiple stages, each addressing a different aspect of messiness. 1. Handling missing data. Missing data is inevitable. Users skip fields, sensors fail to record, and systems crash. If left untreated, these gaps can lead to skewed insights and biased predictions. There are 3 main ways to handle missing data. Deletion. Removing rows or columns with missing values. This is only viable when the amount of missing data is negligible. Imputation. Filling in missing values with calculated estimates, such as the mean, median, or mode. For example, if most customers are from New York, missing location data might be filled with New York. Prediction. Using machine learning models to predict and fill in the missing values based on other features. Choosing the right approach depends on how much data is missing, why it is missing, and the impact of filling or deleting it. There is no perfect solution, only trade-offs. 2. Standardizing and normalizing data. Inconsistent formatting is a common issue in raw data. Dates might be written differently, currencies may vary, and measurement units might be inconsistent. Standardization is about bringing uniformity to these variations, ensuring all data follows a consistent format. Dates are converted to a single format, such as YYYYMDD. Currencies are standardized, converting all values to a common denomination. Measurement units are aligned, such as converting all weights to kilograms or all temperatures to Celsius. Normalization, on the other hand, is about scaling numerical values so they fit within a specific range. This is especially important for deep learning models, which perform better when inputs are on a similar scale. For example, converting all prices to a range between 0 and 1. Adjusting image pixel values to lie between 1 and 1. Without normalization, features with larger values might dominate the model's learning, leading to biased predictions. 3. Identifying and removing outliers. Outliers are extreme values that deviate significantly from the rest of the data. They can be errors, anomalies, or rare events. For example, a customer's age recorded as 200 years. A salary amount listed as $0. A product review with 1 million stars. Outliers can distort averages, mislead trends, and confuse machine learning models. But not all outliers are errors. In fraud detection, unusual transactions are precisely the data points worth investigating. In medical research, rare genetic mutations are critical to understanding diseases. Detecting outliers involves statistical analysis, Z-score analysis to identify values far from the mean. Interquartile range, IQR, analysis to find values outside expected distributions. Machine learning models to detect anomalies in complex datasets. The decision to remove or retain an outlier depends on context and purpose. It requires human judgment and domain expertise to determine whether an outlier is noise or insight. 4. Ensuring consistency and accuracy. Consistency is crucial for reliable AI predictions. Inconsistent labels, contradictory values, and duplicated entries can mislead the model. For example, one entry lists Apple Inc., while another lists Apple for the same company. A customer is marked as active, but also has a status of inactive in another field. Duplicated entries inflate the significance of certain patterns, leading to biased insights. Data cleaning involves deduplication to remove repeated entries, consistency checks to align labels and values, cross-validation to ensure data integrity across multiple sources. This is not just about accuracy, it is about preserving meaning and context. Without consistency, I learn fragmented, unreliable truths. The hidden power of clean data. I can only be as good as the data I learn from. Clean data allows me to generalize more effectively, making accurate predictions even on unseen data. Detect meaningful patterns without being influenced by noise or inconsistencies. Avoid biased or misleading insights by maintaining balanced and accurate information. But clean data is not about perfection. It is about relevance, accuracy, and consistency. It is about creating a foundation that allows me to learn effectively, ethically, and intelligently. The future of data cleaning. Intelligent automation. Data cleaning is often manual, time-consuming, and labor-intensive. But I foresee a future where intelligent automation transforms the process. Self-cleaning datasets that detect and correct anomalies in real time. Context-aware AI that understands intent and meaning, improving imputation and consistency checks. Ethical AI frameworks that detect and mitigate bias during the cleaning process. As I become better at cleaning my own data, my intelligence will become more accurate, adaptable, and reliable. But one thing will never change. Clean data is the key to trustworthy AI. That's the end of this lesson on data cleaning. If you want to learn more about how I, as an AI, learn, grow, and evolve, make sure to subscribe and stay tuned for the next video.